Hey guys, this is Mrs. Harbin, and we are in Unit 3, which is all about radicals and exponents, and today we are going to look at adding and subtracting radicals. Our life application for the unit is this. The student will use the skills God has blessed him with and will examine his comprehension of new material and be diligent to study until he has a firm understanding. Now, this is something that we have talked about repeatedly, that God has given you gifts and talents and abilities. He's given you the ability to reason and to solve things logically, and he expects you to use those gifts and abilities. And it's your responsibility then to examine the new material, whether it's watching these slides and taking notes, or rewatching them if you don't understand, or coming to see me in person and asking questions. But it's your job to examine that material and be diligent that you study until you have a firm understanding. So you shouldn't just be watching this and going, I don't get it, and moving on to the next one. If you have questions, it is your responsibility to come and ask me and make sure that we can get those questions answered. Let's do a quick lesson opener for a review. Simplify these expressions by combining like terms. Pause the video, try this on your own, and resume the video when you've done these three. In simplifying these expressions, we know that we have to combine a like term. And if you remember, a like term is it has to have the identical variable, and that variable has to be raised to an identical power. So here we have two x terms. We have a 5x and a negative x. So we know that we can combine those, and then we have two constant terms with no variable, positive 3 and positive 6. In our second expression, we've got an 8a and a negative 3a. We can combine both of those. And then we have a negative 7b and a positive 7b. We can combine those. And then in our last expression, we have an x squared term with no other x squared terms, so we can't combine that with anything. We have a positive x and a 6x, which we can combine. And then we have two constant terms that we can combine. Now, don't forget that we can't combine this x squared term with anything because it's squared, while our other x terms are just being raised to the first power. So when we combine those terms, we get 4x plus 9 in the top. Our middle expression becomes 5a because negative 7b plus 7b zeroes out. And our third expression becomes 4x squared plus 7x minus 2. All right, try simplifying these expressions. Pause the video, resume when you're ready to check your answers. All right, in the top expression, we can combine 3x and negative 2x, and then we can combine 5y and negative 8y, because they have the same exponents being raised to the same power. When we combine, we're just going to add or subtract the coefficients based on this sign that's in front of those coefficients. In our second expression, we have an AB term, and while all of our other terms have a and b, none of them have a and b raised to the first power. Then we have an a squared b term, and over here we have an a squared b term. So we can combine that positive 3 and that negative 9 a squared b. And then we have an ab squared term, and there are no other ab squared terms with a to the first power and b squared. So when we combine those terms, in the top we get x minus 3y, and in the bottom we get negative 6a squared b plus 12ab plus 4ab squared. Now notice how we have these arranged. We have them arranged with the first term in the highest degree first. So here we have a comes first in the alphabet, so a squared comes first before a to the first power. And then the b's are in reverse order, with our b squared term coming last. And here a b to the first in the middle. Our lesson objective for today, now moving forward past the warm-up, is that you, the student, will use addition and subtraction to simplify expressions involving radicals. Now we know that like terms are terms that have the same variable raised to the same exponent. Got that in there twice, the same exponent. So if you look at these three, our base is x, our variable is x being raised to the 1/3 power. Here we have 2x, same exponent, being raised to the 1/3 power. And here we have 5 being raised to the 1/2 power. Based on our definition of like terms, these first two are like terms, and this last one is not. because it's not being raised to the 1/3 power and it doesn't have an x. If we wanted to add these, we would have 3x to the 1/3 power, just like adding like terms before. Now, we know that fractional exponents can be written as radicals. So if you remember what we did previously, we changed this to a radical. So x to the 1/3 can be written like this. X to the first power with an index of 3. 2x to the 1/3 can also be written as a radical, as can 5x, or 5 to the 1/2. 2x to the 1/3 would be written like this, x to the first power raised to the third index, being multiplied by 2 on the outside, and 5 to the 1/2 would be written like this, 5 to the first power with an index of 2. The same rules apply when we combine our radicals. Like radicals are radicals that have the same radicand and the same index. So we have x, 3x, cubed root of 3x, cubed root of x, and square root of 5. If we're looking at our definition here, they have to have the same radicand and the same index. Well, these two have the same index, but not the same radicand. So we would not be able to combine those. This 5 has a totally different index and a totally different radicand. Now, if we remove this 3 and we had it on the outside, then we would be able to combine it because they would have the same radicand and the same index. So once we remove that 3, we can combine it. And we would just write it as, imagine there's a 1 right here, we would have 4, and then our cubed root of x. So it's kind of like an exponent. In fact, it's just another way to write an exponent, which is what we saw last class. Let's talk about adding and subtracting radicals now. It's just like combining like terms. First, we want to simplify each radical. That's the steps where we do the prime factorization. We remove any parts of the radical, any of the factors that have square or cube or perfect roots. Then we combine like radicals by adding or subtracting their rational factors. Those are the numbers outside the roots. So when we had 3, I don't know what happened there, 3, and then we had the cubed root of x just a minute ago. This is the rational part. That's what we're combining. Kind of like the coefficient when we combine like terms. So let's try a few of these together. We want to simplify 4 root 3 and 2 root 3. According to our first step, we want to simplify our radicals. Well, we can't simplify the square root of 3, so it's as simple as we can make it. Step 2, if you remember, is combine like radicals by adding or subtracting their rational factors. Here are the rational factors. So we're going to just combine those. 4 plus 2 times the square root of 3, and we get 6 square root of 3. Okay, imagine that this were 4x and 2x. We would combine the coefficients, 4 plus 2, and get 6x. The reason this works is because of the distributive property. It's like we're factoring. If we were to go backwards, we could redistribute that root 3 to the 4 and the 2 and be back at our original equation. So we're factoring out that root 3 and adding their rational numbers, or adding what comes in front of them. Again, these numbers under the square root are going to kind of operate like the variable part of our like terms that we were combining. Okay, let's try to combine these. The first thing that we need to do is simplify our roots. Now, none of these are perfect squares. However, we know that by factoring, we can simplify these roots. So if we were to do the prime factorization of 45, we would get 5 times 9, and 3 times 3 are the factors of 9. So we have 3 times 3 times 5. Don't know why I wrote that one differently. Okay, so that's going to be, since we're doing an index of 2, we have the square root of 3 squared, and then our leftovers, the square root of 5. Okay, 18, let's factor that. 18 can be broken down into 2 and 9 can be broken into 3 and 3. So that leaves us with 3 times 3 times 2. And based on what we did in the previous class, we're looking for groups of 2. There we go. So this one can be broken down into 3 squared and a leftover of 2. And 5 is already prime, so we can't do anything with that. All right, let's go to our next step here. These cancel, and so this becomes 3 times the square root of 5. And the root and the exponent cancel here, so we get 3 times the square root of 2. And then we're left with root 5. Now, which ones can we combine? We can combine the ones that have like radicals. This one has square root of 5, and this one has square root of 5. So those are the two that we can combine. We have 3 square root of 5 minus square root of 5 gives us 2 square root of 5. And this one we can't combine with anything, so it just stays as it is, 3 square root of 2. In general, the square root of x plus the square root of y is not equal to the square root of x plus y. Oop, I went the wrong direction here. So the square root of 5 plus the square root of 2 is not equal to the square root of 7. Okay, let's try this one. Negative 8 times the cubed root of 5 plus 9 times the cubed root of 40 minus 2 times the cubed root of 135. Right now, none of our radicals are the same. However, we know that we can factor these two and maybe simplify our radicals here. This 5 is already a prime number, so it can't be simplified. But 40 can be simplified. The factors of 40, I'm going to do 8 and 5. 5 is prime. The factors of 8 are 4 and 2. And the factors of 4 are 2 and 2. So that leaves us with 2 times 2 times 2 times 5. Because I'm looking for the cubed root, I'm looking for groups of 3. And here's a group of 3. So this can be rewritten as 3 times 2 cubed times the square root of 5. And this one, 135, I'm going to need some room for that. Let's divide that one by 5. And that is 2 and 7, which is 9 times 3. And 9 can be broken down into 3 and 3. So we're left with 3 times 3 times 3 times 5. Again, cubed root, so we're looking for groups of 3. So this one can be written as the cube root of 3 times 3 times 3, 3 cubed, and then our leftover times the square root of 5. All right, let's see what this looks like simplified here. Got a few more steps. Okay, we now have this cancels out, so we're left with 2. So we now have 9 times 2 times the cube root of 5. And that gives us 18 times the cubed root of 5. And here we have our original 2 times now this, which cancels, 3 times the cubed root of 5, and that's where we get our 6. All right, we now have cubed root of 5, cubed root of 5, cubed root of 5, all identical radicands. So now we can combine the rational numbers that are outside the radicals. And when we do so, we get 4, clicked button, too fast. We get 4 times the cubed root of 5, negative 8 plus 18 minus 6. All right, we've got one last example. Pause the video, try this one on your own. I'm not going to do the factoring on the screen. When you think you have it solved, come back and check your work. All right, simplifying both of these radicals, we get 2x times 5 times square root of 2 minus our original 5 times 2x times 2x. That gives us 10x times the square root of 2x minus 10x times the square root of 2x, which equals 0. Remember that when you're listing your factors, not only do you need to do the numbers, but you also need to do the x's. And then because our index is 2, we're looking for groups of 2. So we have 2x, and then we have our leftovers that stay under the square root, 2x. That's where that came from. Don't forget to do exponents factoring or variable factoring as well as number factoring.